Welcome to PME channel, and today's topic is production of amplitude modulated wave. And first we will go through its block diagram. Block diagram is just like this. Here we have got a signal empty. This is you can say adder circuit. You can just call it as an adder circuit. One is the carrier wave that is given as an input to adder circuit, and then this is modulating signal empty. Now, what is the function of the adder circuit? It just adds these two signals, X is equal to MT plus CT. And now this input XT, which is the sum of modulating signal and carrier wave, it has been fed to square law device. This is the square law device. And the input to square law device is XT, and the output to square law device is this one. Yt is equal to Bxt plus Cxt whole square. Yt is equal to Bxt plus Cxt whole square. This is Yt. And now we just substituted the value of Xt. The value of Xt has been given to be this one, Am sin omega t plus Ac sin omega Ct. And I will just write for the matter of convenience. This is Am sin omega mt plus Ac sin omega Ct. Now, what role is performed by this square law device? So this is the input Xt, Am sin omega t plus Ac sin omega Ct. Now Yt is B is a constant, B multiplied by Xt plus C multiplied by Xt square. Noted down here we have got Xc square. Now we will substitute the value of this Xt. We will get Yt is equal to B Am sin omega mt plus Ac sin omega Ct. Here I have substituted value for this Xt. Again this is B Am sin omega mt plus Ac sin omega Ct. This value has been put here. And now plus C into Am sin omega mt plus Ac sin omega Ct whole square. So we have dealt with this part. C multiplied by, we have just put in the value of Xt here and square of this. So now we will simplify it. This will remain same, B Am sin omega mt plus Ac sin omega Ct. Now we will open up this. This will be Am square sin square omega t plus Ac square sin square omega Ct plus twice of Am Ac sin omega mt sin omega Ct. Just like this. And now we will make use of two formulas. One formula is, now we have got this square term. This is unwanted term. We don't want square term. And then here is the multiplication. We shall make use of two formulas. One is sin square A is equal to 1 minus cos 2A by 2. When I shall apply it on sin square omega mt, this is 1 minus cos 2 omega mt divided by 2. Similarly, sin square omega Ct will be equal to 1 minus cos twice of omega Ct divided by 2. And now I shall be putting these values here. I shall be putting values here and here. And then one more formula that I shall be using is sin A. Sin B is equal to half of cos A minus B minus cos A plus B. I shall be applying this formula on this section. This section. This is multiplied by 2. So what I shall write here, 2 sin omega ct into sin omega mt. This is equal to cos omega c minus omega m into c minus cos omega c plus omega m into t. So we got this. I substituted these two values here. And after putting this value, 1 minus cos 2 omega mt by 2. What I got is c square by 2 am square plus ac square minus c by 2 am square cos 2 omega mt. I got one frequency 2 omega mt. Another frequency 2 omega ct by opening up this expression. And then we got these two frequencies omega c minus omega m and omega c plus omega. These are the two frequencies that we got. In addition to that, we have got this BAM sin omega mt. So we have got sin omega mt frequency as well as sin omega ct frequency. Now I have got frequencies noted down. One frequency omega m, second frequency omega c, third frequency 2 omega m, fourth frequency on 2 omega ct, fifth frequency omega c minus omega m, and then this frequency, which is you can say sixth frequency, is this. So we got 6 frequency, but we require only 3 frequency: omega c minus omega m, and the third frequency that we require is omega c plus omega m. We require these 3 frequencies in output: carrier frequency and then omega c minus omega m. Modulating signal frequency subtracted from carrier frequency, and then modulating frequency added to carrier frequency. We need these 3 frequencies, and here we have got, we need 3 frequencies, but we have got 6 frequencies. If you see here, we have got 6 frequencies. Just note it down. We have got 6 frequencies. It means 3 frequencies have to be filtered out. We want to filter out these 3 frequencies. Which frequencies we want to filter out? We don't need this frequency. We don't need this frequency 2 omega m. We don't need 2 omega c as well. We don't need these frequencies, and I put crosses on them, the frequencies that we don't need. And these are the frequencies that we need. These three frequencies we need. Now, what is the role of a band pass filter? Now, I will again go to this block diagram. Starting from the beginning, this plus is just an adder. This plus is just an adder. You can call it adder. I will write it here. Adder. It just sums up the two frequencies. Which frequencies? CT and MT. And we got XT. XT is the sum of these two frequencies, and XT is AM sine omega MT and AC sine omega CT. It is the sum of these two signals. One is carrier wave, other is modulating signal. And then this is the square device. It works on this formula. And after applying this formula, we get 6 frequencies. Here we get 6 frequencies. But we need 3 frequencies. And these 3 frequencies have to be shunted out. To this task of selection of 3 frequencies, here I have got only 3 frequencies. Means omega C minus omega M, and the third frequency omega C plus omega N. Here I have got 6 frequencies. From this 3 frequencies are eliminated. I write with F. F means frequency. These 3 frequencies are eliminated, and only these 3 are passed on to the output. In this way, we get the signal which is to be transmitted. Now this should be fed to the transmitter. From here, now this is a transmittable signal. This signal is a transmittable signal. This is required to be fed to the output. So this is the role of, you can say, whole of the system which functions, whose input is carrier signal and modulating signal. It gives us XT. From XT we get YT. It has got 6 frequencies. 3 frequencies are filtered out by band pass filter, and these 3 frequencies come out. This is the transmittable signal. It should be fed to the transmitter. Now we have got this block diagram of transmitter here. Again, I will repeat the above process: message signal and carrier signal. They are amplitude modulated by making use of adder circuit, and then square law device, and then filter circuit. Amplitude modulator is a sum total of these 3 circuits: adder circuit, square law device, and then band pass filter. So all these 3 have been shown in this one block. And from here I got a amplitude modulator which is made up of above 3 circuits. The output of this is modulated wave. This is given to power amplifier, which increases its power, and then here it is transmitted. Now here it is transmitted through antenna. So this power amplifier, it has increased the power. Why we have increased the power? Because we want less number of less repeaters. Because signal, due to some losses, it loses its power and it has to be re-strengthened by a repeater, which receives the coming signal, amplifies it, and then retransmits it. This is the job of a repeater. We transmit waves with three frequencies omega C minus omega C plus omega m, by increasing its power so that we should require lesser number of repeaters. With these words, I finish this lecture.